equation of the form ax squared plus bx plus c equal to 0, where the coefficients a, b and c are real numbers and a is not equal to 0, is called a quadratic equation. In a quadratic equation, b squared minus 4ac is called the discriminant of the quadratic equation and is denoted by the capital letter D. You know the formula to find the roots of a quadratic equation. If the discriminant is greater than 0, then the roots of a quadratic equation are real and distinct. They can be obtained by using the given formulae. If the discriminant is 0, then the roots of a quadratic equation are real and equal. They are minus b divided by 2a. Let's solve the equation 2x squared plus 3x plus 1 equal to 0. The discriminant of this quadratic equation is 1, which is greater than 0. Therefore, the roots of the equation are minus 1 divided by 2 and minus 1. Let's consider another quadratic equation 2x squared plus 2x plus 1 equal to 0. First, we'll find the discriminant. The discriminant obtained is minus 4, which is less than 0. In such cases, how can you solve the quadratic equation? We know that the roots of a quadratic equation ax squared plus bx plus c equal to 0 are as shown. Since the discriminant is less than 0, the value of b squared minus 4ac is negative. Therefore, we can write the discriminant in the formula as minus 1 multiplied by 4ac minus b squared. We know that the square root of minus 1 is I. Therefore, the roots of the quadratic equation, where the discriminant is less than 0, can be obtained by using the formulae given. The roots of the quadratic equation are complex numbers and they are conjugate to each other. Let's now solve the given quadratic equation 2x squared plus 2x plus 1 equal to 0. We have already calculated the discriminant of the equation, which is less than 0. Therefore, the roots of the quadratic equation are as shown. On simplification, we get the roots of the quadratic equation as minus 1 plus I whole divided by 2 and minus 1 minus I whole divided by 2. In all the three cases, we observed that a quadratic equation has two roots. In general, a polynomial equation has at least one root. This is called the fundamental theorem of algebra. As a result of this theorem, a polynomial equation of degree n has n roots. Let's review the properties of the roots of a quadratic equation. The sum of the roots of a quadratic equation is equal to minus b divided by a. The product of the roots of a quadratic equation is equal to c divided by a.